let's do this problem right here. The question is asking determine the internal shear force and the moment acting at point C in the beam. So let's see what we can do. So first of all, we have to put the forces acting on it. So we know this one has only the vertical forces, vertical force. Let's say this is By, and this one can have possibly two forces, Ax and Ay. So let's put it Ax and Ay. So from the look of this diagram, we can say we can take the movement around A and we can solve for By. But however, uh, we have a distributed force right here, so we have to find the exact force that is acting in this object. So to find that, I have to calculate the force. Like since this is a triangular force, so I have to use area of triangle to find the force that is acting on 1/3 of the triangle. So if it's a rectangle, it's going to act in the middle. If it's triangle, if you find it, you will get in the 1/3 from the top, the highest part. So let's calculate it. So the height is 4 kilopascal. It's half time height times the length, right? That's the equation for the triangle. Then if you calculate multiply this one by 6, that's gonna give us, let's say this is Fy. So if it's Fy, this is going to be 2 times 6, 12 kilopascal. So if it's Fy, it's going to act, it's going to be 12 kilopascal. So we have to raise this and put that in 1/3 of this picture. So it's going to be 1/3 from the highest, the top height. So it's going to be somewhere here, 1/3. So this is going to be 12 kilopascal. Let's say Fy equal Fy, and if it's 1/3, the distance is going to be 2 feet from here. So we say this is 1/3 distance. So from now I can calculate the By. So to calculate the By, I have to take the moment around A, because moment around A has two unknown variables. B has only one. That's why I'm taking the moment around A to cancel these forces. So if I take this one, I will get moment around A is going to give me, if I take clockwise positive, and it's going to be equal to 0, and 12 kilopascal is 4 feet away from this A, so it's going to be 4 times, and it's acting clockwise, therefore it's going to be positive. 4 times 4, 4 times 12. Then By is pulling this object in the counterclockwise, so it's going to be negative By times times the total distance is 12 feet, so it's going to multiply by 12. So these are the only two forces that are creating the movement, so therefore we can say these two are equal to 0. Then from this one I can find the By is going to be equal to 4 kilopascal. So this is a By. Since we have found out the By, now we can, our main purpose is to find the C, shear force and the normal force acting on the point C. So to do that, I can do the method of section. So to do that, I cut this part separately and solve this problem. So I'm going to draw this separately. So we have a B right here. Since the answer is positive, our assumption is right, it's acting upside. So that's the only possible way, right? So Vy is 4 kilopascal, and we are gonna have normal force in C. This is just the assumption direction. It can be any direction, but I just assume this is the direction. So when we get the answer negative or positive, we can determine whether it is right or wrong. Also, I assume VC acts in this direction, and then let's take movement in the clockwise. So from now on I can solve this picture. So first of all, if I take the horizontal forces, so sigma f of x is equal to 0 in statics, and if I take this direction positive and solve for this one, I will get nc in the negative direction, so it's going to be minus nc is equal to 0. Therefore nc is equal to 0, because in the horizontal we don't have any other forces acting on it, so it's a direct answer, it's equal to 0. And if I find the vertical components, vertical forces, it's also equal to let's see. So we have, if I take upper direction positive, and we have two forces acting on this object. One is shear force and the other one is Vy. Shear force is acting down, so it's going to be minus Vc, and Vy is acting upside, so it's going to be plus Vy, and it's 4 kilopascal equal to 0. So from this, it's a direct answer. Vc is going to be equal to 4 kilopascal. Now we have found the shear force. My final thing to find the moment around C. So if I take the moment around C clockwise and solve this one, so we are gonna have MC, that's gonna be positive since I'm taking the clockwise positive. So MC is gonna be positive. The only other force that's creating the moment is By, and the distance between this is 6 feet. So it's gonna be, it's pushing this object in the counterclockwise. Therefore it's going to be negative 4 times 6, which is equal to 0. So from now I can say that this is going to be equal to 24. So MC is equal to 24. The answer is positive. Therefore our assumption is right. It's acting in the clockwise. 24 kilopascal feet, not kilo pounds, not kilopascal, kilo pounds feet. So this is my final answer, and that's all we have to find. The question is asking find the internal shear force and moment at point C in the beam, internal shear force, moment, and that's all we need to find. I hope you guys liked this video. See you next time.